Good morning. In the last classes, in the earlier classes, we discussed about the analysis of linear systems. What are the basic systems? What are the classification of systems? So basically, systems are. Do you know systems? What is meant by system? System is nothing but it is the one which takes some signals. Signal. Suppose x of t is a signal. A system will take x of t as a signal, it processes something, and it will give y of t as another signal. So it takes signals, it processes and gives some resultant signal. That is called system. Okay, systems are classified into four types: linear system, non-linear system, time variant system, and time invariant systems. Okay. So what is meant by linear system? A system is said to be linear if it satisfies the scaling property and superposition theorem. Okay, a system is said to be linear system if it satisfies the scaling property as well as superposition theorem. See here the system is there. This is the system. It is having the input f of t and output r of t. Okay, here also input is also called as excitation signal or input signal, that is f of t, and r of t is output, that is also called as response, that is r of t, that is response. So here f of t is the input signal and r of t is the output signal. So if f of t is related to r of t, or if r of t is related to f of t, vice versa, if these two are related vice versa, or some constant into input signal is related to some constant into output signal, or some constant into output signal related to some constant into input signal, this relation is said as a scaling property. Okay. Okay, input is related to output or output is related to input, so these two are related vice versa. Okay, next, coming to the superposition theorem. Superposition theorem is if f1 of t is related to r1 of t and f2 of t is related to r2 of t, then the sum of these two, f1 of t plus f2 of t, is related to r1 of t plus r2 of t. Then this property is called the superposition property or superposition theorem. On the whole, by combining these two properties, scaling property and superposition theorem, it gives linearity property. And here we remember, in linear systems the output varies linearly according to the input. Output varies linearly according to the input. Okay, so on the whole, the linearity property is defined as some alpha, some constant into f1 of t plus some constant into f2 of t, that is alpha into f1 of t plus beta into f2 of t, is related to alpha into r1 of t plus beta into r2 of t. So finally, a linear system is the system which satisfies the scaling and superposition theorem, and its output changes linearly with a change in input. Okay, so this is called the linear system. Then coming to the time invariant system. What is invariant and variant? So here the system whose parameters do not change with respect to time. Okay, the system whose parameters do not change with respect to time is called time invariant system. Okay, see, if f of t is the input signal, r of t is the output signal, f of t is related to r of t or r of t is related to f of t, then f of t minus tau is related to r of t minus tau. Okay, the system which is linear and time invariant is called as linear time invariant system. Okay, here we have two properties, linearity property as well as invariant property. So if the system is combinedly have these properties, then it is called linear time invariant system. Okay, the system which is linear and time invariant. Okay, that is called linear time invariant system. What is meant by non-linear system? Non-linear system which does not satisfy the scaling and superposition theorems, then that is called non-linear system. Okay, then time variant system. Then the properties of linear time invariant systems. We have some four properties of linear time invariant system. What are those four properties? that is cumulative property, distributive property, associative property, and static and dynamic property. Cumulative property, distributive property, associative property, final one is static and dynamic property. How the cumulative property is defined? See, if this is the system, this box is nothing but the system having the impulse response h of t, okay, is having the input signal f of t and the output signal r of t. Output signal is also called as response. Okay, so this response of this system is defined as the input f of t convolved with the impulse response, that is f of t star h of t, f of t convolution with h of t, or we can write this as h of t convolved with f of t, h of t convolved with f of t. This is called cumulative property. Next one is distributive property. Here we are distributing. The response is expressed like this. See, here the system having the impulse responses h1 of t and h2 of t. These two are added here. Okay, the system is having the input signal f of t and the output signal r of t. Okay, f of t is the input signal and r of t is the output signal, right? So if r1 of t is defined as f1 of t star h1 of t, r1 of t is nothing but the response of the first system. So r1 of t is equal to f1 of t, that is input signal convolved with the impulse response. Similarly, r2 of t is equal to f2 of t convolved with h2 of t. Then r1 of t plus r2 of t is equal to f1 of t convolution with h1 of t plus f2 of t convolution with h2 of t. This f of t, this f1 of t, f2 of t can be treated as f of t, that is f of t, make it as common. So f of t convolution with h1 of t plus h2 of t. Okay, so here it is a distributed. So this is called distributive property. Next one is associative property. So next one is associative property. So r1 of t is expressed as f of t convolution with h1 of t convolved with h2 of t whole. These two are considered as a square brackets. Similarly, this r2 of t can be expressed as f of t convolved with h1 of t this whole function convolved with h2 of t. Similarly, r3 of t can be expressed as f of t convolved with h2 of t whole convolved with h1 of t. Okay, this is called associative property. Next one is static and dynamic property. What we already know about the static systems and dynamic systems. Static systems are generally memoryless systems. Dynamic systems are having some memory. Memoryless system means the system doesn't have any storage storage ability. Okay, so static systems are memoryless systems. That is, the output depends only on the present state of the input. Suppose in these systems, the impulse response h of t is 0 for t is less than or equal to 0. For t is less than or equal to 0. Okay, so coming to the dynamic systems, see, static systems means memoryless systems. So the output of the system depends on the present state of the input. So it will take the present state of the input. Okay, right. Coming to the dynamic system, these are having some memory. So storage device, it consisting of some storage device. So dynamic system is one whose output depends on the present and past inputs. Okay, the output depends on present and past inputs, right? Next, coming to the transfer function of the LTI system. What is meant by LTI system? Linear time invariant system. This is also called as a system function. System function, a system is there. What is its function? A system, in general, we can say that a system is having one input and output. How to express the system function from the given system? System function is nothing but output by input. Suppose x of t is the input, y of t is the output. Then the ratio of output signal to the input signal is nothing but system function, right? Or it is also called as transfer function. Okay, right? It is y of t by x of t. Y of t is output signal, x of t is input signal, right? So here, that is, in general, we can say that the system function is expressed mathematically like that, or transfer function is expressed mathematically like that in general. But here we are taking an exponential signal as the input signal, that is x of t equal to e power j omega t. That is exponential signal as the input signal. Okay, right? Then y of t becomes y of t equal to the input signal x of t convolved with the impulse response h of t, right? Where x of t is the x of t is an exponential signal, that is e power j omega t, right? And h of t is impulse response. Then y of t can be expressed as so here we are taking the convolution formula. Convolution formula is integral minus infinity to infinity h of t into x of t minus tau d tau, right? Or we can write this as integral minus infinity to infinity x of h of t into e power j omega t is replaced by t minus tau. Okay, j omega t minus tau. Okay, t minus tau. Right, right. D tau. That equal to integral minus infinity to infinity h of t into, this is in the form of e power a plus b. So e power a plus b is e power a into e power b. That is e power j omega t into e power minus j omega tau d tau. So extract e power j omega t outside. So e power j omega t into integral minus infinity to infinity h of t into e power minus j omega tau d tau, right? So it is equal to e power j omega t into t into integral minus infinity infinity x of t into e power minus j omega t dt, or integral, that is nothing but x of omega, but it is h of t into e power j omega tau d tau, that is h of omega. So y of t becomes e power j omega t into h of omega. E power j omega t is nothing but x of t, so that is y of t equal to x of t into h of omega. Let it be considered as equation number 1, where h of omega is integral minus infinity to infinity h of t into e power minus j omega tau d tau. What is h of omega? H of omega is nothing but a Fourier transform of h of t. What is h of t? How to extract h of t from h of omega? By taking inverse Fourier transform of h of omega. Okay, so h of t can be extracted as 1 by 2 pi integral minus infinity to infinity h of omega into e power j omega tau d tau. This is the inverse Fourier transform of h of omega. This is the Fourier transform of h of t, right? Thus, the above equation states that the response of a LTI system to complex exponential function of frequency omega is same as the input multiplied by constant called transfer function. Here transfer function is h of omega. H of omega equal to y of t by x of t. Transfer function h of omega, right? So the transfer function h of omega is given by h of omega equal to y of t by x of t at x of t equal to e power j omega t, right? So if we express the input in terms of its Fourier transform, what is input here? E power j omega t. Okay, so in terms of Fourier transform, then x of t is equal to x. How to find x of t? So that by taking inverse Fourier transform of x of omega, so that is 1 by 2 pi into integral minus infinity to infinity x of omega into e power plus j omega t d omega, right? So substitute this expression, or the expression of x of t, substitute this expression in equation number 1. What is equation number 1? Y of t equal to x of t into h of omega. So x of t value is 1 by 2 pi into integral minus infinity to infinity x of omega into e power j omega t d omega, right? Substitute this entire value in equation number 1, so that y of t becomes 1 by 2 pi integral minus infinity to infinity x of omega into h of omega into e power j omega t d omega, right? So 1 by 2 pi integral minus infinity to infinity x of omega into h of omega whole into e power j omega t d omega. But x of product of x of omega and h of omega will be considered as y of omega, where y of omega is x of omega into h of omega, or h of omega is y of omega by x of omega. Okay, this is represented in terms of time domain. It is represented in terms of frequency domain. Okay, this is the transfer function of system, or this is also called as a system function. This is transfer function of LTI system or system function. Okay, next we will go for the impulse response. Okay, let us consider the system having the input signal x of n and the output signal y of n. Okay, so how to get this y of n? Y of n equal to transformation of the input signal. Y of n is nothing but the output signal. So output signal is nothing but the transformation of the y of x of n, transformation of the input signal. Let us consider the input signal is the unit impulse function. Unit impulse function is nothing but at n here at n equal to 0 or at t equal to 0 it exists. Its value is 1. Impulse function is defined as delta n or delta t equal to 1 at if it is delta t, then it is t equal to 0. Delta t equal to 1 at t equal to 0, or delta n equal to 1 at n equal to 0, right? So if the input to the LTI system is unit impulse, then x of n is delta of n. Then y of n is nothing but transformation of x of n, that is transformation of delta of n. So the response y of n is the impulse response. Okay, we know that the input signal x of n can be represented in terms of weighted impulses, that is y of n equal to transformation of x of n. Okay, so y of n can be represented as transformation of x of n. X of n is nothing but x of n is inverse Fourier transform of x of k. Okay, x of n is uh, represented like this. So sigma k equal to minus infinity to infinity x of k into delta of n minus k. Okay, this can be rearranged like this: sigma k equal to minus infinity to infinity x of k into transformation of delta of n minus k, or it is x of k into transformation of delta of n minus k can be written as h of n comma k. For time invariant systems, h of n comma k is equal to h of n minus k. So replace h of n comma k by h of n minus k. Okay, so sigma k equal to minus infinity infinity x of k into h of n minus k is nothing but the convolution of x of n and h of n, x of n convolved with h of n. So y of n becomes x of n convolved with h of n. Okay, let us do some problems on this LTI systems. Okay, let us do some problems on LTI systems. Okay, here the problem is given like this: let the system function of a LTI system be 1 by j omega plus 2. What is the output of the system for an input 0.8 whole power t into u of t? 0.8 whole power t into u of t. So here the system function or a transfer function, both are same. So how it is represented? The system function and transfer function, that is represented by h of omega. H of omega is given as 1 by j omega plus 2, right? Then what is the output of the system for an input? Here the input x of t is given as 0.8 whole power t into u of t, and the output what is output here? Y of t. We have to find out the y of t, but h of omega is given. Okay, h of omega is given. From that h of omega we can find out h of t. H of t is nothing but inverse Fourier transform of h of omega. By writing the inverse Fourier transform of h of omega, we will get h of t. X of t is already there. Y of t is nothing but x of t convolved with h of t. X of t convolved with h of t is nothing but y of t, right? So according to convolution theorem, y of t equal to x of t convolved with h of t. This is h of t actually. So we can write the formula as y of t equal to integral minus infinity infinity h of tau into x of t minus tau d tau. This is the convolution theorem formula. Okay, so impulse response of LTI system is h of omega is given as 1 by j omega plus 2, but h of t is nothing but inverse Fourier transform of h of omega. We know that inverse Fourier transform of 1 by a plus j omega is e power minus at into u of t. E power minus at into u of t. It is also looking like the same as 1 by a plus j omega 1 by 2 plus j omega. So e power minus 2t into u of t. H of t is e power minus 2t into u of t, right? So from this equation, y of t equal to x of t converted with h of t, or it is h of tau into x of t minus tau d tau, right? So this is h of tau is e power minus 2 tau into u tau into x of tau is 0.8 whole power tau into d tau, but here u of t is not written. Why? Because u of t is nothing but unit step function. It is defined as u of t equal to 1 for t is greater than or equal to 0. That's why here the limits may be changed. Limits are from 0 to infinity only. Why? Because u of t exists from 0 to infinity only. In the next step, we show like this. So see here, y of t equal to integral 0 to infinity e power minus 2 tau into 0.8 whole power t into 0.8 whole power minus tau d tau. There is no u of t. Why? Because its value is 1 only. Okay, then extract 0.8 whole power t outside. Integral 0 to infinity e power minus 2 tau into 0.8 whole power minus tau d tau. Take minus tau as common. So e power 2 into 0.8 whole power minus tau d tau. Let us consider 0.8 into e power tau whole power minus 1 as a. Then it will become a tau d tau. Okay, 0.8 whole power t with integral 0 to infinity a tau d tau. So it is integral e power ax dx. It is in the form of integral e power integral a power x dx, that is a power x by log a. Okay, a power x by log a. So it is 0.8 whole power t into a power tau by log a with limits 0 infinity, right? So what is a here? 0.8 into e power 2 whole power minus 1. So substitute the value of a at here. 0.8 into e power 2 whole power minus 1 into tau, that is minus tau with limits 0 infinity. So by substituting all these values, we will get the y of t value is 0.8 whole power t by log 0.8 into e power 2. This will become 0.8 whole power t by log 0.8 plus 2 log e to the base e. Log e to the base e value is 1. So it is log 0.8 plus 2. Okay. So then y of t becomes 0.8 whole power t into log 0.8 plus 2. Okay, that is the output response y of t with given h of t and x of t, right? Next problem. Next, the problem is given as show that a system with excitation x of t. What is excitation? Excitation means input signal. Okay, excitation x of t and response y of t described by the response y of t is equal to x of t minus 5 plus x of 3 minus t is linear or non-causal and non-invertible. We have to show the system y of t as linear, non-causal and non-invertible. Okay, so given the response is like this. Given the response of the system y of t is x of t minus 5 plus x of 3 minus t, right? So linearity, first of all we have to check the linearity. How to check the linearity property? It obeys the scaling property as well as superposition theorem. If it satisfies the scaling property as well as superposition theorem, then we can say that the system is linear. Okay, let two inputs x1 of t and x2 of t are applied and their respective outputs y1 of t and y2 of t are given by, right? Y1 of t becomes x1 of t minus 5 plus x1 of 3 minus t. Similarly, y2 of t is equal to x2 of t minus 5 plus x2 of 3 minus t, right? Then y1 of t plus y2, by adding these two, y1 of t plus y2 of t is equal to x1 of t minus 5 plus x1 of 3 minus t plus x2 of t minus 5 plus x2 of 3 minus t. Let it consider and let it be considered as equation number 1, right? When an input x1 of t plus x2 of t is applied, then output becomes y1 of t plus y2 of t. That whole will be considered as y3 of t, right? So x1 of t plus x2 of t whole will be applied to this input. Then we will get y1 of t plus y2 of t. By adding these two, we will get x1 of t minus 5 plus x2 of t minus 5 plus x1 of 3 minus t plus x2 of 3 minus t. Or it is uh, writing only x1 terms at the one side. So x1 of t minus 5 plus x1 of 3 minus t plus x2 of t minus 5 plus x2 of 3 minus t. That is considered as equation number 2. Okay, equation number 2. Then from equations 1 and 2, we have y1 of t plus y2 of t whole will be considered as y3 of t. Thus, the system is satisfying the superposition theorem. Hence, the system is linear. Scaling property, it also satisfies the scaling property here, right? So, it satisfies both scaling as well as superposition theorems. Then it will become linear system. Then coming to the causality system, causality. So consider the given system y of t is equal to x of t minus 5 plus x of 3 minus t, right? So put t equal to 0 in the above expression. So y of 0 becomes x of 0 minus 5, that is x of minus 5 plus x of 3 minus t, that is x of 3. If put 1 in the above expression, then t equal to 1, y of 1 equal to x of 1 minus 5, that is minus 4 plus x of 3 minus 1, x of 2. Similarly for 2, y of 2 equal to x of 2 minus 5 minus 3, x of 3 minus 2, 1. See here x of 3 indicates that the output, see this x of 3 indicates that the output at t equal to 0 is dependent on the input value at t equal to 3 and t equal to minus 5, right? Hence, the system depends on past and future values of inputs. Okay. In other cases, the output of the system is depending on the past and future values of the input. Hence, the given system is non-causal system. Okay. Non-causal system. Hence, the given system is non-causal system. So, it is the second condition. And third condition is invertibility. Invertibility property. Consider the given system y of t equal to x of t minus 5 plus x of 3 minus t. For t equal to 0, as we already substituted, that is y of 0 is equal to x of minus 5 plus x of 3, right? In the above instant, output at y equal to 0 is obtained by adding the inputs at minus 4 and 2, right? X of 0 minus 5, x of 3 minus 0. Okay, that is x, the inputs x at minus 4 and x at plus 2. Several inputs signals are responsible for same output. Okay, here the several input signals are responsible. What are the several input signals? X of minus 4, x of minus 5, that is at minus 4 value, x of 3 at minus 2 value. So these several input signals are responsible for same output, that is y of 0. Thus the system is non-invertible. So here the given system is causal linear system, non-causal system, and non-invertible system. Okay, next the given problem is a system has an impulse response h of t is equal to 4 into e power minus 4t into u of t. This is the given system of the impulse response. Impulse response is given. Find the graph and response of the system to x of t. Here x of t, that is input signal, is given as rectangular function of 2 of t minus 1 by 4. Rectangular function of 2 of t minus 1 by 4. Okay, right. So we have to find out the response, that is y of t we have to find out. So the impulse response of a system is h of t equal to 4 into e power minus 4t into u of t, which is shown like this. This is exponentially decaying function. Its amplitude is 4 and this is exponentially decaying. Its function is e power minus 4t. This is the exponentially decaying function 4 into e power minus 4t. The input signal x of t is given as a rectangular function of 2t minus 2 by 4. That is a rectangular function of 2t minus 1 by 2. Rectangular function of 2t minus 1 by 2. Right? So, which is shown like this. Here the rectangular function is shown like this. If t is 0, then it is rectangular of 0.5. Rectangular of 0.5. If t equal to 1, it is 2 minus 1 by 2, that is 4 minus 1 by 2, 3 by 2, it is 1.5. Okay? Rectangular function of 1.5. If t is 2, 4 minus 1 by 2, that is 3.5. Okay? T is 1, 2 minus 0.5, that is 1.5. Okay. Okay, so it is shown like this. It is already shown like this. So rectangular function is where is exists between minus 0.25 to minus 0.75. Its amplitude is 1. Okay. Then the response of the system can be obtained as y of t equal to x of t converted with h of t. That is y of t is equal to integral minus infinity to infinity, integral minus infinity to infinity h of k into x of t minus k dk. This is the convolution formula, mathematical formula of the convolution, right? Okay. Then h of k and x of k signals are shown in below figures. See, this is h of k signal and x of k is this one, figure 3 and figure 4. The time reversal form of x of k is nothing but x of minus k, that is nothing but mirror image of x of k is represented as this mirror image of this one. So this will be represented in this side. Okay, so this is this exists between 0.25 and 0.75. This is the mirror image of the above one, right? Then for t is less than 0, the signal x of t minus k can be represented as shown in figure 6. Okay, x of t minus k, x of t minus k, time will be shifted towards right side by k units. So it will be represented as figure 6 as x of t minus k as this is 0.25 plus t, this is 0.75 plus t. Amplitude will not change. Then k equal to 0 to 0.75 from here to here, 0.75 plus t is the time period over which both x of t minus k and h of k are present. H of k is this one. X of t minus k with k equal to 0 to 0.75 plus t. Okay, then y of t becomes for t equal to less than 0, it is from 0 to 0.75 plus t, 1.4 into e power minus 4k dk. 1.4 into e power minus 4k dk. 1.4 is nothing but the h of k value. Okay, h of k value. H of k is 4 into e 4 minus 4t, right? Or 4 into e 4 minus 4k. Okay, see here. So 1.4 into e 4 minus 4k into dk. So it is e 4 minus 4k with the limits 0 to 0.75 plus k plus t. This is 4 by minus 4, that is minus 1 into e power. By substituting this one, we will get 1 minus e power minus 3 into e power minus 4t, or it is equal to 1 minus 0.0498 into e power minus 4t. Let it be considered as equation number 1. So we derived, we analyze this one for t is less than 0. Now we are analyzing this for t is greater than 0. Okay, if the signal x of t minus k can be represented as shown in figure, this is x of t minus k, right? It will be shifted towards right side by k units. So k is varying from t plus 0.25 to t plus 0.75 is the time period over which both x of t minus k and h of k are present. Hence, it is integral t plus 0.75 to t plus t plus 0.25 to t plus 0.75 into 1 into 4 into e 4 minus 4k dk. Here the amplitude is 1, right? 1. Okay, it is we can write this 4, extract this 4 outside, so 4 by minus 4 into e power minus 4k into minus 4k with limits of t plus 0.25 to t plus 0.75. Okay, so by simply substituting, y of t becomes a 0.318 into e power minus 4t for t is greater than 0. That is equation number 2. Y of t for t is less than 0 is 1 minus 0.0498 into e power minus 4t. Right? So for t equal to 0, x of t minus k is equal to x of minus k as shown in figure 5. Where is figure 5? Figure 5 is figure 5 is this one. Okay, so okay, for t equal to 0 case, we will analyze in the next class. So up to this I will conclude the today's session. Okay, so okay, remaining this problem we will explain in the next class. Okay, thank you.